what we do in pressure vessels for calculating the allowable loads.
We do the WRC 107.
That is when we have already available that external loads. We check how much stresses they are creating and whether that load is permitted or not, right?
Yes, yes,
So by using WRC. Here also some methodology is given. It is not depending upon any other things. It is fully covered in this annexure P. So if you see here, see there are normally three forces and three moments, right? You might have seen in the drawing also.
yes, yes.
The three primary forces will be there and three moments will be there.
Moment also.
But in that, mainly that your radial force and longitudinal and circumferential moments, these three are important. Okay. So in API only, these three are considered for design. Okay,
It's
because
only that thrust and
thrust,
longitudinal
longitudinal
circumferential
moment
moment.
and the circumferential moment. Only these three loads, we have considered in this API 650. Okay. So if you go about this procedure, okay, first it calculates the, you can see there is some table available for modulus of elasticity and also the thermal expansion. Why it is given? Because it has also given the methodology to calculate the cell
Still different.
deflection and also the rotation. See, because of temperature, because these tanks are very large, even small temperature will be creating a radial growth of the shell, right? So I should be able to know that how much radially my shell can grow because of the thermal expansion. Okay, these things are not available in ASME.
Yes,
Why? Because it talks about lots of variety of pressure vessel, lots of things are included. So it is not possible there to give any single formula. But here it is
yes.
talking about very specific configuration. So definitely lots of things can be given.
Considered.
So
But sir, what about the rotation?
sorry,
So
rotation.
the cell deflects.
Yeah,
Cell
rotation
deflection
also
for
is
the
given.
rotation.
This is the shell deflection, and if you go further, you will get the rotation of shell also. Okay. See, because
Means वो क्या होता है क्या मतलब cell deflection?
see, if you are fixing a nozzle, so definitely the it it is like radial direction. My shell is anchored at this nozzle location because piping will be connected, right?
Yes.
So if it is not restrained, then there will not be any deflection. But if it is restrained, then it may happen that slightly deflection. So this is talking about the deflection of the nozzle from the center line of, so it is not talking about the shell rotation.
Okay, okay.
Getting
That
that?
angular rotation
Yeah, angular rotation of,
angular deflection.
hums. See, angular deflection in angular terms will be called rotation only, right?
Yes.
Getting it, right? So unstraight rotation of the shell at the center of the nozzle to shell connection resulting from the product head shall be determined. Okay. So what I meant, see, this is not because of the loading, but because of the product head. See, the product is there inside this tank, right? So all shell tries to buckle in between. It will try to bend like this.
Yes.
Okay, like this shell. So this will create slight rotation in the angle. Okay, so because
Okay.
this rotation is resulting from the product head of the tank. So how much rotation it can have, that is given by this formula. Okay, so this is about your expansion of the shell and rotation. Till now we have not seen what is the loads which we can have. Okay,
Yes.
now let us find out what is the methodology to calculate the loads. Okay, so it starts with here P2.7, determination of allowable loads for shell opening. So how we'll determine what is the maximum load available. Okay, we are not checking it like section division. There we have the load, we check the stresses, right? Here we
Yes. Yes.
determine what is the maximum value of load which it can have. So there is a difference, right?
Yes.
So first of
So
all,
we are calculating stress or
we are
stress.
calculating the load. Means the three loads we saw, right? Radial
Yes.
or axial load, the two moments, longitudinal
Two
moments and
moments.
circumference. So these three things will be calculating the value of it.
Okay.
Getting it? Okay, so let us
Means
see what.
what with respect to the size of nozzle or something like that.
No, definitely that will depend. No, we have just started, so definitely it will depend on the size. So let us see how the size of the tank, because it will depend upon the size of the tank also, right? Other than your
Ah, yes.
nozzle. What is the elevation of the nozzle? That will also have some implication, right? Because if it is located very close to the shell, means bottom of the shell, it will have more strengthening. If it is located away, then it can take less load, right? So let us see how, what are the different factors. Once we see the procedure, that will be clear that how many factors are affecting that. Okay, so first we have to find out three non-dimensional quantities. What are these three non-dimensional quantities? First is XA divided by RT, means under root of RT. Now what is XA? XA, if you see here in the figure, this is my shell. I'll just delete all this. So this is the configuration for which we are discussing. Okay, so my nozzle OD is 2A. Okay, the position of the nozzle, the extreme part is located at XA, the center line is located at L, and the bottommost is located at XB. Okay,
Okay.
so if I have L which is known, I already have the XC value. So I can calculate XA and XB based on the size, right? XA will be
Yes.
nothing but XC plus 2A divided by 2 means A.
Yes.
XB will be
L
X,
L plus A.
yeah, L plus A. XB will be L minus A. XC will be equal to L, right? So we can
Yes.
calculate this 3 XA, XB, XC, right?
Yes. Yes.
Once I have that, what are the other things? Other things are already known. R is the radius of the tank. T is the thickness of the shell. So I can calculate these three non-dimensional quantities.
Yes.
Yes. So
Yes.
once this is known, I can use figure P.3a and 3b to calculate three coefficients. There are three coefficients which we need to calculate: YC, YF, and YL. Okay. So
Yes.
now let us calculate that YC, YF. Okay. It will be available by P.4a, P.4b. This is about different. We just talking about just mentioning this axis on a layout. We'll come to that. Let us find this YC, YF, and YL. So if we go to P.4a, So it was referring this value and it was trying to mark this. Yes, we'll come to that. We'll go to P.4a.
Basically,
4a will give us the YF and YL value.
YL.
So if you see this graph, YF or YL, it will be determined by this lambda. Lambda is what? Lambda is nothing but A. A is the radius of my nozzle, which we saw, right?
Yes, yes.
By
It is.
square root of RT. Okay. So with this value, we will have the lambda. So let us see if it is coming at this. We will have the YL and YC value both. Y means YF and YL value.
Yes.
Right? We can proceed like this. We'll get the YF and YL. YC is not there in this. YC is there in the next graph. If you see, this is YC. Okay.
Yes.
So YC is also depending upon the same factor. Okay. So point, like if you are proceeding here, this graph will give me the YC value. Okay. So we have three coefficients and three non-dimensional quantity. Now what to do with that? Okay, we have three non-dimensional quantities and three coefficients. How to use them? Construct four boundaries for figure P.3a and two boundaries for P.3b. See, if you read this, it will not be clear. We need to go to that para. Hence where it is created. Okay.
Sir, in that Y is in 3.4b, if
Mhm.
my value is comes in 3 or 5, so what will the Y is?
Here in this,
4b, 3.4b, no, BB, 4a, B.
here, if it is
This
coming
one.
beyond this,
If yes. So what will be my value?
mostly it should not be going with that. Okay, because if the ratio, if you see here, the other is also limited to only two value. So this lambda factor is maximum 2. So that means, see, if you see here in the square root, this quantity is very large. This is the radius multiplied with the thickness. Okay, and this is the nozzle size. So you will not get this value more than 2. Okay, if you are getting, so that definitely something might be given here. What to do with that, but mostly because this is a storage tank you're talking about, you will not get that. Okay, nothing is given, so that means it will not be mostly going in that region. Okay, because it has not given anything to refer or see when it is going beyond that. Okay, so
Yes.
generally it will not go beyond that. Okay, so now once we have
Yes.
all these value, we will come to this figure. See, this we have to create. This is called a nomogram, construction of a nomogram. So there are two nomograms which we need to create. This is the first one, this is the second one. First one will have four boundaries. This is one, then two, three, four. Okay, how to create that, that will depend upon this value, how to start it. Okay, so how this value will be known? This is actually greater of zero point 0.1 or this value. This value we have already have, xb is known, square root rt is also known. So definitely we can
Yes.
get this value. So
Yes.
greater of this will be the starting point of this line. Because you can see that line slope is 1 by 1. So once this point is known, I can draw this line, right?
Yes.
Okay, so once I'm able to draw this line, okay, the next point will start from here. Okay, one, this is also 1:1 slope. All the lines are with 1:1 slope. Okay, so here also, this also we can calculate the second. See, first we'll draw this, then we'll try to draw this. Okay, how we'll get this? By using this. So this will depend upon XA. So this is also, all the factors are known. So we can definitely get this value. So this will give me this point. Okay, so from here I can start. Okay, and we'll come to this point. Okay, so here these lines are, two lines are already fixed. This will join -1 to -1, and this will join 1 to -1. Getting that?
Yes.
So these two lines are fixed. This and this we need to find out and then draw it. So once this is drawn, now your how to calculate the values. So if you see here, this axis is your lambda divided by 2yf. See, we calculated yf already. Lambda is not known. We'll calculate this lambda. Okay, 2yf fr divided by fp. Fr is the radial force which we want to calculate. So this is unknown. Okay.
Yes. Run.
Yeah. Fp is the thrust pressure. This will depend upon, like, if I have an opening. Let's go to that figure. Like if we're talking about this opening, we can calculate the pressure due to static head at this point, at the center of it. Okay. I can calculate the pressure, multiply that pressure with the area of this opening, inside
It
opening.
means total pressure into
Not this pressure
internal pressure plus static.
from the center line and multiplied with the area. That will give me the FP value. Okay. So only thing which is unknown here is now lambda. So lambda, how will calculate? See, lambda can be calculated. Let us see how it is given. Yeah. YC, YF, YL will calculate it, and then, okay. So let us see this figure. Okay, this will give me the, so these figures will give me the stiffness coefficient. Okay, that is based on your L by 2A ratio. What is L by 2A? L, if you see, is the height of that nozzle. L we saw, right? This is L.
Yes.
So now you can see that this is also important where it is located. L by 2A will give me this value. Okay, this ratio. If the ratio is changing, I need to refer different figure. Okay, here that LA will change. Okay, so that three different coefficient, K, KR, KL, and KC, which we need to calculate. So how to calculate that? Once I have that L by 2A, I have the graph, and then if I have R by T value, R is the tank radius divided by thickness. So definitely it will be very large value. So once I have that, I will see what is my AR line. So if it is something in between, I can just imagine that line and then consider a straight horizontal line where it is touching. Like if it is, see, my imaginary line is like this. So it is cutting this here. So I will get this KC value for this. Similarly, all this KC, KR, and KL I will have. Okay. Once I have that, these are about different ratios. So LA to is 2.5. Okay. Okay. So lambda is nothing but actually A by under root T, which we saw already.
Yes. Yes.
Lambda is already defined here. Okay. So see that factors will be used for some different purpose, I guess. Where it is used, KL, KR, and KC, we'll see that. Okay, that is used here to determine the connections between different loads, like if FR, ML, and MC. You know, what is my like ML will create theta because of that load. So how much deflection will be there because of ML? Similarly, MC will create how much deflection of the nozzle. And this is the radial deformation because of this axial load. So that will be
Means
useful.
here we cannot means identify the stress. We just
Which one?
identify the
Sorry.
this loading. ये
Yeah.
लोडिंग में मतलब हम लोग एंगल और खाली डिफॉर्मेशन ही फाइंड आउट करेंगे स्ट्रेस नहीं फाइंड आउट करेंगे
नहीं, स्ट्रेस नहीं
सही
फाइंड आउट करेंगे, पहले तो लोड फाइंड, ये एफ आर का मैक्सिमम वैल्यू है वो फाइंड आउट करेंगे। वो अभी किया नहीं है हमने, तो हम लोग देखने लगे के एल, के सी और के आर का वैल्यू ना। So
yes
where we were at the monogram. Okay, so we had, now we have this lambda value also. Okay, so
yes
if we are in this monogram, what can be my maximum value of this? Okay, so this is limited by, this point, whether it is like how we used to draw it. Okay, we are in different. Yes, so these are the 2 points which will determine. Okay, so whatever is the minimum, okay, this can be larger, this can be smaller. So in
yes
this case, this is larger, definitely by look wise. We will calculate the
yes
value, then only we'll come to know which is large. But if the graph is coming like this, that means this is larger. So this point is the maximum value of your lambda divided by 2YF FR by FP. So like if this value is coming at zero point 0.6, this value will become equal to 0.6 maximum.
yes
All other
yes
factors are already known, so I can calculate FR, right? Getting it?
YF and YP
So
we
this,
already found that
this if I equate is equal to, this value is already known, right? It is 0.1 or whatever
yeah
we,
you
let us say it's 0.6.
can't see
Got here 0.6. So this value will be 0.6. So that is the maximum value of my lambda divided by 2, because this is the axis of that. It can vary from here to here. Okay.
yes
So that will give me the maximum value of this. So if I equate this, now the equation is complete. I have all the values of other factors. Only unknown is FR. So I can get that value.
yes you can find it
This will give me the axial force. Similarly, I can find this maximum value of ML. Okay, this point which is going at the extreme, this will give you the ML value. If I relate this to this point, it will give me ML value. Okay, maximum.
so FP value किधर मिलेगा
Huh?
FP
If we saw no that axial thrust pressure, the static head multiplied with the
yes yes
of,
okay
that is your FP value. Okay, so like that we can equate. MC will be finded by this graph. Okay, So in this axis also your FR is coming, so we need to consider this also, like whatever is the lowest for my this factor, that will be my limiting of this axis, right? So,
Yes.
so F bar value will depend upon all these 1, 2, and this is the third, on all the three coefficients. Okay. While your MC and ML is depending upon only one. See, ML can be positive or negative depending upon which value is the maximum. Okay. So there is a detailed calculation also given as a problem. So if you go through that, it will be very clear that how we are using it. Step by step it is given. It has also created the nomogram using those values. Okay. So you'll be able to use that, how we have to apply this. Okay. So you can create an Excel sheet out of this, try to create that. Okay.
Okay.
Got it. So after solving these equations, you will get the maximum value of FR, maximum value of ML, maximum value of MC. Okay. So this is about external loading on tanks. Okay.
So,
Others
sir,
are.
with respect to that value,
Uh-huh.
you find out that deflection and deformation, no?
Yes.
With respect to
Now,
FL,
if we
ML.
have FR, FP, MC, then we can go to the to find the radial deflection and radial projection and deflection
Yes. Yes.
here. Okay. So this is a relation between the elastic deformation which will happen because of my radial load and the deflections which might happen because of my ML and MC.
फिर मतलब सर उसमें मतलब कैसे पता चलेगा कि वो मतलब कितना चाहिए और कितना नहीं?
क्या कितना चाहिए?
मतलब वो QL QC का जो भी
चाहिए।
वैल्यू आएगा
हाँ, थीटा एल थीटा सी,
उसका
ये कितना चाहिए
हाँ
वो नहीं
हाँ
आएगा।
सर
सी मैक्सिमम लोड आपने ऑलरेडी निकाल लिया ना, उस लोड की वजह से कितना डिफ्लेक्शन आएगा वो दिखा रहा है। इसका कुछ लिमिट नहीं
तो
है,
ओके
तो इसके ऊपर डिपेंड कर रहा है, एमएल के ऊपर डिपेंड कर रहा है। सो उतना आपको
तो
डिफ्लेक्शन अलाउ करना पड़ेगा,
बाकी
स्ट्रेस इज
हाँ
नॉट
वो
क्रिएटेड।
तो वो मतलब क्लाइंट स्पेक के हिसाब से देखना पड़ेगा
हाँ,
मींस हाउ मच डिफ्लेक्शन सभी WR जो निकाला डिफॉर्मेशन तो
हाँ,
वो मतलब कितना अलाउएबल है मतलब समथिंग कुछ मुझे वैल्यू
इसका कुछ
मिला
अलाउबल
एक्स
नहीं है,
वैल्यू
ये तुमको दे रहा है कि कितना ये रेडियली मूव करेगा। तो इसके साथ जब भी आप पाइप कनेक्ट कर रहे हो, तो उतना मूवमेंट का प्रोविजन उसमें आपको रखना पड़ेगा।
ओके ओके
थीटा अभी नोजल टिल्ट हो रहा है, तो उतना पाइप में फ्रीडम होना चाहिए कि वो उतना उसको अलाउ करे थीटा एल रोटेट होने के लिए, नहीं तो फिर क्या होगा, स्ट्रेसेस बढ़ जाएंगे और वो टूट जाएगा।
तो मतलब वो एज पर मतलब हम एएसएम में कैसा वो फेल वगैरह होता है तो फ्लैंज का रेटिंग
टूट
बढ़ाना
जाएगा,
पड़ेगा
इसमें
मतलब
आपको लोड
उसको
से ही सीधे
यूजी
कंपेयर हो जाएगा ना। डायरेक्टली यू आर गेटिंग द मैक्सिमम लोड विच यू कैन अप्लाई।
ओके
लोड
तो मतलब इससे ज्यादा पाइपिंग में लोड देना नहीं है
लोड लगा ही नहीं सकते, इससे लोड आया तो फिर वो फेल हो जाएगा। दैट इज द लोड विच इज लिमिटेड इन दिस, नॉट द स्ट्रेसेस। स्ट्रेस तो इसमें हम लोग कहीं कैलकुलेट ही नहीं करते ना।
यस इसमें तो सर मतलब इसमें ऐसा कुछ फ्लैंज का रेटिंग मतलब 300 रेटिंग आएगा ही नहीं
नहीं, फ्लैंज का रेटिंग नहीं आएगा इसमें, प्रेशर है ही नहीं। वी आर टॉकिंग अबाउट वेरी स्मॉल प्रेशर,
यस
these are atmospheric tanks, so there is no question of any higher rating of flange. Okay,
ओके
now try to go through it and try to complete that Excel sheet by including this also. Let us see if you are able to create. If you have any issue, please let me know. Okay, that where you are getting stuck. Okay, so we'll work out in that. Okay, so these are the main annexures which we have referred. There are many others. You can just go through them.